guys, today we are going to be doing class 5th, chapter 1. We are travelers part 1. This is part 6. I said that you watch part 1, part 2, part 3, part 4, part 5. The link is in the description. Now, let's get started in the let us do. 1. Write 5 numbers between the numbers this number and this number, or it can be 23,568 and 24,234. You have to write any pi numbers, but they have to just between these two numbers. Now, you may think one step ahead of the lowest number, it's known as between. So why we can't just do this? 200. We'll almost write the exact same number and then do that and add 1, just 1, 9. Like this you can do it. Like 23,000. Look. 23,570. That still counts, right? You can do this. Write 5. No, this. Write 5 numbers that are more than 38,125 but less than 38,600. Now we can use the exact same, but you can also do like this, like 3, 8, 5, it will be 5, 5, 5, and then a 9, 9. That's still less than the second number and then more than the first number. You can do this. And if you want to extend the pattern more, 38,500 598. There. We can do it like this. It's little messy. On there, Ravi's car has driven for 56,987 kilometers till now. Shweta's car has been driven 67,543 kilometers. Whose car has driven more? Wow, there's so like are Ravi and Shweta like travelers? Oh, that's the name. We are travelers. I think they're referring we as these two. Huh. And we have to just not tell what is between them. We have to just tell which is bigger, which has been driven more. And there's a 6 at the 10,000th place, but in Ravi's car there's only 5 at the 10,000th place. Meaning that Shweta's car has been driven more. Yay, Shretal. There. Now, the following are the prices of different electric prices. Arrange the prices in ascending order or increasing order. Ascending order is the smallest number to the biggest number. Now, here it is. Firstly, like some videos back, I used to like color code them and then arrange it. I am doing that. The first one is black. Cool. So this is black. Next is red. And then next is blue. And then next is green. And the next is yellow. And then the next is orange. The last color. Now we have six colors arranged in colors. Colors. Now we can see that green is the smallest, only being near like 50,000. No, yes, 50,000. So meaning green is the first one. No, it actually orange is first. Then green. I never noticed. There is like almost 40,000. This one is the green is 50,000. Now the next one is this red one, which has almost 90,000, or it is 89,999. Then right one step ahead of it is black, like one ahead. Like if these two electric bikes were shown, then obviously they'll pick, like they both have almost the exact same value. So what is worth it of spending a little over 1 rupee? Yeah. Then the next one is this yellow. It's the yellow one with 39,000 or 34,000 to be exact. And then we'll put yellow. And then the lastly is blue. It's like that. Now let's go to the next one. Nah, not that. The following table shows the population of some towns. Arrange them in descending order, decreasing order. Now, descending order is the biggest number to the smallest number. Biggest number, smallest. Now, I could do it with color coding, but I can also do it like snapping. Gogi! It worked! Yes, my snaps. What? I don't know why I snap. I could try. Now this is in a descending order. Don't assume it as ascending order. This is decreasing every time. First one is 6. This, which has biggest. We can break these into categories. One, the 4,000 that has 4 on the 10,000 place. Red, and then we can do it the pie with these, and then the blue with the 6. So there's only one. So that goes all the way in the last. Then this, this, and then lastly that we can do it as a combination detail. Now next one is find numbers between 42,750 and 5,053,500 such that ones, tens, and hundreds and all digits at 0. Now the load is not that much. Well, we can do it like this. 5, no, I remove this. 53000. That has ones, tens, and hundreds all 0. Now in this you may get some reminders from your previous classes. Write the following numbers in the expanding form. What has been done for you? If you can't remember expanding form from class 3rd and 4th, you notice that this is a number and we have to break it and using by plus. It's just to break the ones, tens, 100,000 to 10,000 and so on, and then replace it with the zeros. And like this example, there's the 700, here the 7, and then the place value is 7, then this is 8, then this is 80, because this is on the tens place, and then this is 3 on the ones place that has just alone 3. Now, say, yeah, this is going to take a long time, so snap! It works! Okay, you already know. In this, there is 8062, and then we'll write 8000 plus 60 plus 2. Like this it is. Now, here I have done for you. Now, here is a bit confusing part that most 5th standards get stumped on. Fill in the blanks with the correct answer. Share your thoughts in the class. Now, here's one example 983, which is 90 tens, okay? But they should be hundreds, right? Yes, the tens, if you multiply 90 multiplied by 10, that still equals to 900. What is this? 83 ones? Yes, there is 83 ones. Look, 90 tens is 900, so the remaining 83 will be ones, like this. Now, the next one is little tricky. There is 18 ones, but tens, you may think 60. Now, see, because if you do it 60 plus 18, that becomes 78. But how about you decrease it? 50 plus that. Oh, it becomes 68. Meaning at the tens there will be 5. Now, wow. Now, here's another one. This one. 607. Meaning just write 607 ones. No, it's not like that. There's 400s. How do you do it to make it full? Minus. Firstly, that's the number, and then we'll minus it by 400. That equals to 207. Meaning we have to write 207 in the ones place. That's a lot. But is this taking too much time? Yes. Then why you can't just complete the time with a snap? Oh my goinky dragons! It worked. See, look, it's very confusing. I can't even understand it properly. Look, this is 4,000 and then this is 600, 1,600 because that, then this becomes 5,000. Wait, this becomes 5,000 and then oh, this becomes 5,000, that becomes 600 and that gets rid to 1. Then, yay! It works, it works, it works, it works, it works. See. And wait, are we getting to the end of the chapter? Yay! Finally, this entire journey is about to end. 9. 9. Fill in the blanks with the correct answers. Now, in this, I have did a shorts about this. It's an example of class 4s. The link is in the description. Now, in this, there's a how many notes of 10 are there in 7,934? Now, if you haven't watched that short, I can say it again. Look, as I said in the short, there's this tens place. Then we'll cut the number behind the tens place, meaning this is the answer and that's actually the answer. Next one is how many notes of 100 there are in that exact same number. Now we have to cut the ones behind it, meaning there is 79. 79. Next one is how many thousands there are in that exact same number. Now we have to cut it behind the thousands. Let's cut. Ooh, it's 1,000. The answer. Now here gets a little complicated. Now this part I have put. How many 500 notes there are in that number? Now it's saying that hint hint hint, observe the answer of 3, meaning the C answer. As we see, the 500 is like half of the thousands. Now that means that why we can't just multiply with each other? That's much simpler. Meaning that's 14. Simple, simple. Now there's this next one. How many notes of 10 there are in 65,342? Now we have to cut the numbers behind, meaning we have to cut this too, meaning that this is 6,534. Now the next one is how many notes of 100 there are. Now we can just cut the 2 which is behind it and then that's our answer. 653. Now the next one is that how many thousands there are in 50. Exact same. Now we can do it as like this. We have to cut the like the last number from the previous question. Now it is 65, and that's obvious. Now we have to multiply this by 2. And if you don't know the table of 65, then remember the decimals. And I think you don't know. Nah, no, not at all. If you plus the 5, so it will get a 0. And if you know the table of 6, I think most of you, meaning that's 12. And then plus 1, that's 13, meaning it's 130. Now we are in the very last question. And yeah, I need a speed up. Chop, chop, chop. I need a speed up right now. The king's horses. Not like that. Once upon a time, there was a king who had a very one of 4 horses. He had 20 horses of the best breed. The horses were kept in a royal stable and cared by a caretaker. One night, a thief stole one of the horses. Being punishment, the caretaker arranged the horses in the stable shown in the picture here. And the next day, when the king came to check on the horses, the caretaker led him around the square stable. Please count the number of horses on each side, Your Majesty, he said. The king counted 5 horses along each side. We have 5 horses on each side, and there are 4 sides. So there are 20 horses, Your Majesty. The caretaker explained. Satisfied with the explanation, the king returned to his palace. But wait, were there really 20 horses in the stable? Count the horses one by one and check. Was there a mistake in the caretaker's explanation? That following night, the thief stole another horse from the stable. Only 18 horses remained. The caretaker once cleverly arranged the 18 horses, so there were 5 horses on each side of the square stable. How can you think he was able to do it? Arrange the 18 horses in the stable with 5 on each side. How many more horses can the thief steal before the king notices something wrong? Try making arrangements yourself. Okay. Now, in this, as we saw at the top, there were 20 horses. This is what the caretaker arranged. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are only 19 horses. And somehow, 5, 5, 5, 5. You may think, is there something going over my head? Or I think this is just completely scamming. Yes, the caretaker is. Because this and this, they are following the exact same horses. See, here's 5, and then here's a 5. Yeah, this particular horse sits in these 2 rows, meaning it just doubles it automatically. Now, to do that, we have to place 2 horses on 2 corners or 1. Now, we have to do something. I'm firstly going to do it the 20 horses or the 18 horses one, and then now we have to play like this. How let's do it like a 2 here, a 2 here. Yeah. Now we are going to place 1 here. And then let's make 2 here again. Let's count. There's 8, 9. There's 9 horses we just placed. And there's a 10, 11, 12, 13, 14, 15, 16, 17, 18. 2. There's 18 horses. Meaning now the king is satisfied with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 horses in his stable. However, he thinks that each side is 5, meaning, and there are 4 sides in a square, meaning that there is 20 horses. But we tricked the king's mind. Wow, the king can't even realize this simple tempting. who made him the king. Now we have to do this. How many more horses that can the thief steal before the king notices something wrong? Well, let's try to the minimalist. How about 15? Is that possible? Let's see. 1, and then a 2, then a 3, then a 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, I think that's not going to work. Let's do that, but that's 15. How about wait, let's remove this one and then this one and then this one. We have an extra horse to spare. There. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Hey, I think 15. 15 looks obvious. There's only like 3 on this side and 4 on this side. These are taking too much space. Meaning, now we have to erase this and apply that. And then erase that and then apply that. Or where there. And then, not that. We'll remove this and then replace it. Fail. There is some horses left. Play. Play. Idea. How about we can just move this horse there? Meaning we got an extra one. Remove this and then there. But we are allowed. Wow, this is very confusing. Can you do it? And now the entire chapter ends. Yep. Yeah, that's my cat. So, thanks for watching. Please subscribe, like to this video for more tech joke solutions like this. If I'm going to get 2k views on this video, I'm going to post chapter 2, which I don't know. I don't study in facts. I'm bored. So yeah. So this is me going bye 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 bye. Finally, that's 6 parts, and finally one chapter has ended.